This is a simply supported beam. Here we have two types of vertical reactions and one type of horizontal reaction due to this pinned support on the left side. Now let's use our first equilibrium equation, which is the sum of all forces acting on the horizontal direction. It turns out that the only force that is acting in the horizontal direction is actually the horizontal reaction itself, and it has nothing to react to. So this reaction will simply be equal to 0. Now let's use our second equilibrium equation. It is the sum of all moments that are rotating against chosen point of the beam. I chose point A, which is on top of the pinned support on the left hand side. Point B is denoting the top of the roller support. So let's consider our first vertical reaction first. It turns out that the distance between this force and the point A is equal to 0, and thus the corresponding moment also will be equal to 0. Now let's consider our concentrated load equal to 10 kilonewtons. Its distance between the point A and this force is equal to 4. But which sign should we assign to it? Well, let's redraw our beam. Let's drive a nail through the point A and let's load it only with the load equal to 10. It turns out that this system will rotate clockwise, and thus the plus sign in the equation. Now let's consider the final moment, which is caused by the RB reaction. It turns out that this reaction gives our beam the counterclockwise direction rotation. So I will assign a minus sign to this value, and the result of this moment will be the RB reaction times the distance between the point B and A, which is equal to 10 meters. And all of this should be, of course, equal to 0. On the basis of this equation, I can calculate the value of the vertical reaction RB, which simply will be equal to 4 kilonewtons. Luckily, we still are having our third equilibrium equation, which is the sum of all vertical forces should be equal to 0. It turns out that in the vertical direction, we have, of course, our first vertical reaction, RA, which is pointing upwards. We, of course, also have our concentrated load equal to 10 kilonewtons, and we have our second vertical reaction. And on this basis, I can calculate our RA vertical reaction, which simply will be equal to 10 minus 4 equal to 6. And there you have it. We have successfully calculated all force reaction in this simply supported beam. I hope you enjoyed our little example. Thank you.